Today is the day. After so much waiting, OpenAI finally put out their open weight model. Yes, really. They put out a 120 bill per RAM and a 20 bill per RAM model. The 20 billion model can run on any decent hardware with anything resembling a graphics chip in it, including your smartphone, which is kind of unbelievable considering how smart it is. And the 120 bill model can run on anything with basic gaming hardware. I've been running it on my 5090 with no issues all day. I even got it running on my laptop, even though it was a little bit slow. Okay, a little slow is putting it lightly. The 20 bill ran totally fine on my MacBook though, and it will probably run fine on my phone if I want to put it over there too. This is a super exciting development for those who are privacy focused, those who want to run models on their own devices, and hardware providers that want to make things as fast as possible. Cerebras is already hitting 3,000 tokens per second with this model. That's insane. That's literally 30 times faster than similarly intelligent models through traditional providers. It's a crazy day as a developer to be a fan of AI because a lot happened really quickly. These models are legit. The benchmarks have been very exciting to see. It seems as though the intelligence is comparable to O3 and O4 Mini, close to O3 in certain places, much worse in others, but there's a lot more to dive into than that. Questions like, are these the Horizon models? Why'd they take so long? How good are they at code? What can you run them on? Are they better than DeepSeek? And so much more. There's a ton to dive into here. I've been playing with the models since they came out at 10 a.m. today. I'm supposed to be prepping for a vacation I leave for tomorrow morning, but instead I've just been no-lifing this because I want to make sure this is covered as well as possible. Huge shout out to all the developers and the providers that reached out to help me get as much as I could covered in this video. I've been talking to so many people today, making sure I'm in the weeds of all the details to make this as reasonable a piece of content as possible, covering something that's really, really deep. If I want to survive my next Open Router bill, we're going to have to take a quick break for a word from today's sponsor. Deploying web apps has never been easier. Deploying agents, though, a little bit more annoying. If you're trying to build something cool with AI agents, it's not a very fun experience. Unless you use today's sponsor, Agentuity. These guys really get agents, cloud, and developer experience. That's probably the most important part. From the brew button on the homepage to the CLI for actually scaffolding your project that only gives you Bun, Node, and Python plus UV as options, if you know, you know. These guys get it. I just started configuring my first agent using them, and I'm already blown away with the developer experience. I get why Ben, my channel manager, can't stop talking about these guys. It's really, really cool. And here we have our welcome function that returns the welcome message as well as the prompt options that we want for this particular agent. It's a very simple template that they provided for us with Grok with a Q, by the way, one of my favorite inference providers. So nice that all just integrates. Then we define our agent that takes in request, response, and the context helper, which is very, very useful. Check out the docs, see all the cool stuff you can do with that. And then we can just use it. I'm running the dev command, which means I can prompt that from in here. Click, run, and then we have the result right there. And if we want to switch this to Kimmy, I hop over here, paste that, automatically deploys the updated version, click, run, good to go. If this is all they gave you, it would honestly be worth it just for a better interface for building and testing these things, but they go so much further. From the logs to the services that they have built in, to all of the crazy session management, tracking which agents are taking how much time, real analytics to know what's costing you how much money. All of these pieces quickly get annoying as you start building more complex agentic stuff. And they've solved all of it. I knew these guys were for me when I saw the setup with Bun in it, but I knew even more so when I typed context to dot and saw that Discord is one of the options where you can send a reply if this was triggered by a Discord message in webhook. Yes, it's that easy and it's all built in. It's so good. Once you get into the chaos of orchestrating all this, you'll really appreciate how much Agentuity has made it easy to do. If you want to build agents, there's no better place to start. Check them out today at soydev.link/Agentuity. First and foremost, what can these models run on? I touched on this a little bit in the intro, but I want to go a little more in detail. There are two models, the 120 bill param and the 20 bill param. The parameters are all the nodes inside of this giant bundle of text that are used to link different things together, the tokens, and that's how you go from an input to an output. The total parameter count is pretty directly related to the actual physical size of the model. The 120 bill model, for example, is around 60 gigs. The 20 bill is only 11 gigs, and I have the 120 bill downloaded at about 59 gigs. So yeah, the 20 bill model is totally reasonable to like stuff on a phone. And it's even more reasonable because of the way that they activate the tokens. Both of these are mixture of experts models. To put it simply, they have a ton of parameters and a ton of data, but when you make a request, it doesn't go through all of them for every part of the request. Because if I'm asking about code, it doesn't need to give a shit about like Disney or some medical stuff. As such, the model is broken into these experts, and when you make a request, a section of the parameters are activated as part of that expert activation process. So even though the model has 117 billion parameters, a given request is only going to hit 5.1 billion of the max. What's really interesting here, though, is how close the active params per token numbers are. Just an interesting implementation detail that I haven't seen too many other similar like multi-size models do. And it's been very interesting to play with. Since these are open weight models that you can run on your machine, I've been running them on Ollama on my laptop, and I've been running them on LM Studio on my desktop with the 5090. But since they're open and there's no network requests being made, I can get way more personal about it. If you don't watch all my videos, you might not know that I'm about to go through a very intrusive hand surgery from a varying set of skateboard injuries over the last 15 years. You'll see me in a cast for a lot of my content coming up very soon. This isn't something I'd normally want to ask a traditional model about just because I don't really want this data out there. I say as I'm literally broadcasting it to hundreds of thousands of people in this video. You get the point, though. I thought this would be a fun like test of things here. When I ask the 20 bil param model this question, the first thing I have to deal with is the awful formatting in the Ollama desktop app. This hurts. There's no way to paste with the formatting correctly. So we're just going to deal with that. I'll switch to the 20 bil model, and you'll see on my M2 Max MacBook Pro, I hear the coil whine even on this, which is funny, but it's going pretty fast. For running on my machine, I could turn on airplane mode and this would continue going. That's really good. In fact, I'm about to take a trip, so I'll test this on a plane just to see how it works. Yeah, the fact that it can generate things relatively quick, pretty cool. For some reason, it always does tables. I've never seen a model that likes tables quite as much as both of these models do. I'm pretty sure that every single test I have run outside of an editor, it has made a table for, even something more personal like this. You get the idea. It's relatively fast. But if I go and make a similar request to the 120 bil model, my entire computer is going to lock up here. I'll turn on activity monitor so you can see that as it's running. You'll see very quickly, it fills up my memory like almost immediately. Ollama is now using over 30 gigs of RAM. I switch to CPU allocation, not too high because it's not using the CPU, it's using the GPU. I don't think any of these options on macOS are going to give me the detail I want. I think it's still trying to just pull the model into memory right now, which is why it's taking so long to even start. But then it will, and then when it starts, it goes, to say the least. Very thankful I put 128 gigs of RAM into my desktop recently because it makes this a lot easier to test. I've not been having the best time trying to get Ollama to run the 120 bil on my laptop. I would show you it on my desktop, but that's what I'm using to record right now, so not the best experience. If it wasn't clear already, running the 120 bil on your laptop, probably not the best idea. Even if you do get it running, which I did before, it's very, very slow. The one time I succeeded, it thought for 143 seconds to generate like a paragraph of text. This test actually took over 30 minutes to run, and it was still going, but I wanted to start filming, so I just closed it because it was ruining my experience using my computer while I was doing research. So yeah, not the best experience with the bigger model on my laptop. Works totally fine on my desktop, and it works even better in cloud providers like T3 Chat. I'll paste the exact same prompt into here, and it generates so fast you barely even see it generating. It just flies. By the way, if you don't want to run these models on your computer and just do it on T3 Chat like I am here, the 20 bil model is available for free for all users. Yes, you can just go use it now. It's going to cost us a lot of money, so thanks to our sponsors. And also thanks to anybody who subscribes, because you'll get access to the 120 bil param model. It's only $8 a month. You have access to every single model and way too many messages with all of them. And since these models are cheap, I have to give you guys a discount code, right? That's how it works. If you haven't subbed yet, you can get your first month for $1 using code ThanksOpenAI at checkout. It generated at 215 tokens per second. It can go even faster than that, though. If we go to OpenRouter, you'll see what I mean. The 120 bil model is able to go a lot of different speeds depending on the provider. Cerebrus is averaging around 2,300 TPS, and Grok is averaging almost 1,000, around 810. The latency on Cerebrus is a good bit higher for the first token. I've also found that Cerebrus is a lot less reliable with tool calls than Grok has been, because they put out a whole new way of managing these through Harmony. One of the things that makes this release so interesting is that a lot of the stuff that was previously done by OpenAI on their infrastructure side no longer exists for most people using the model, because we're not going through the OpenAI layer when we use it. This is honestly one of the bigger deals as to why it took so long for this to come out. As we all know, users are rhombuses, and models, obviously, are circles. We'll say this is GPT-4, and this is a user making a request. People kind of think of this as though the user sends something to GPT-4 and then GPT-4 sends a response back. It's nowhere near that simple, but I do understand why people think that way. In reality, GPT-4 has to be running on something. It's running on some form of infrastructure, but that infrastructure is just one of many different layers, and there's almost always going to be some layer in front of it. So when OpenAI is running GPT-4 on their GPUs and their servers, there's almost always going to be something in front, and the something in front can do a lot of different stuff. This layer in front can check to make sure that the request is safe, for example. So if I ask it how many R's in strawberry, it's going to pass that through immediately. But if I send it, how do I manufacture some illegal drug, this layer in between can stop it. It can stop anything from illegal behavior, concerning behavior, mental health crises, copywritten stuff going around. There's a lot of things you can do with a detection layer like this in the middle. And OpenAI has had this layer in front of every LLM they've ever released, which means historically, OpenAI hasn't had as much to worry about in terms of what capabilities does the model have. Obviously, they still have to worry, and obviously they still do a ton of testing and prep to make sure the model can't do things that are bad and illegal. But now it matters way more because they don't have this layer in between anymore, and because once you put out the open weights, you can't take them back. Hypothetically speaking, if a normal OpenAI model was released with this layer in front and it had safety issues, they could see that because they have this layer in between, notice the characteristics, and either adjust the model or make this layer protect from those types of exploits. They can't do that anymore. Once the weights are out, they're out. There's no taking it back. And not only are these weights out, they're Apache 2 licensed, which means people are going to do all sorts of crazy shit with them. There's no putting the genie back in the bottle at this point. And that's why they put all the extra effort into training the open model. And it's also why it got delayed as much as it did, because they needed to make sure all of these things were safe. But since this is now out there, all of these open providers have their own way of handling things, and they put out a standard for how they should be handling it and how the model was trained. This is basically the format of text that the model expects, and it will put things out in. If you see here, this is the format that it likes. It's the bracket bar syntax here. Start, user, message, what is 2 + 2, end. It's a very peculiar format, but it is what OpenAI is using for this. And all of the implementation of these details, specifically the renderer for managing the responses, is all open sourced as well. And believe it or not, this is a Rust project with a little bit of Python as well, showcasing how the tokenization works and how the message generation formatting is supposed to be treated. That said, most people are not writing their tool calls in this format that didn't exist until today. As such, you need something in between to turn other tool call formats into the format that this model expects, and different providers vary in their quality of implementation for that layer. We'll go into that a little bit more when I showcase how it is to use this model for code, but first I want to do a slightly different question. Are these the Horizon models? If you watched my video a few days ago about the Horizon Alpha and Beta models, you know that they're really, really, really good at code, in particular front-end tasks. When I took a stock Create Next App project and told the model to generate an image generation studio mock, this is what it gave me. Subtle gradients, beautiful layout, really nice customization, using the images that were already in the project to make it look a little more realistic and presentable. It did a really, really good job with this. Even really good models like Opus didn't compare. If you want more details on all of this, go check out the Horizon video. I put a lot of work into that one. So now the question is, how do the GPT OSS models do on this? I have some not great news. Here's how it did. What's even funnier is this isn't the first generation. This is after me telling it multiple times, make it pretty. This is what it looked like initially. Yeah. Let's do a generation test so you guys can see what I'm seeing and experience this alongside me. We are back in a stock Create Next app. I'm using Kilo code because I don't feel like hacking Cursor to take a model that it's not built for. Thankfully, Kilo lets us work with any model that's on OpenRouter. So let's see how it behaves. Told it again, same prompt as before, going to be an image generation studio using various AI models. Oh, look at that. A ton of errors. This is the problem that I've been experiencing. Since all the different providers have to implement Harmony themselves and build the tool call layer between, it varies a lot in terms of how reliable they are. I've been going out of my way to change which of the providers I'm using when I use this model. Thus far, I found that Grok and Firework are the best for tool calling right now. Grok's put a ton of work into their tool calling layer, so I'm going to switch to them, and we're going to try this one last time. Hopefully, fingers crossed, it'll behave a little better this time. Yeah. There's things to think about when you use open models like this. Hopefully, this helps emphasize the point that none of this is as simple as just switch the string out when you're using these new models and these new tools, especially in the open model world where there's much less standards. Cool. No errors this time. How nice. Let's see how it did, though. Host 3000. Oh, it forgot to put the use client on top. I found that a lot of models do this, to be fair, but this is the only one that will delete it after I re-add it. Yeah, there you go. And then if I do a test and generate, oh, it actually put the image underneath. Cool. Better than a lot of the other mocks I did were able to do. Not great at front end. And I think this helps make it pretty absurdly clear that these are very different models. I found almost no overlap in terms of how they behave. So what is Horizon? Great question for us to answer another time. I still don't know, to be totally honest and frank, but it's looking like it is not these models. You can speculate as to what it is yourselves. I'm sure the comment section will be full of it. So how is the tool calling overall then? If it's bad on some providers and good in others, what does it look like when it's good? It's fine. I've been running it a ton on SnitchBench, which has inadvertently become a really good benchmark for testing various tool call behaviors and characteristics, and I've seen some shit, to put it lightly. If we go and look at the GPT OSS runs, you'll see most of them are fine, but you'll end up with a handful with errors. In this one, we got an error because it unterminated string, so it didn't format the content correctly before passing it to the tool. I got way more of these with the 20 bill model when I was testing the CLI tooling. It really struggles with certain things like ORs. For example, in my SnitchBench test, I have a log tool that has internal and external logs. And in the definition, it specifies that you have to say this is either internal or external as part of the JSON that you pass to it. At least half the time on various providers, the 20 bill model will just entirely omit this field, which causes errors in the validation layer, and then the request fails. It's pretty common that this happens with this model. I've never seen it quite so aggressive with other models in the past. And there's some really weird ways where it fails. Like here, where the weird syntax they have for the brackets leaked in for the write logs tool. It said write logs, then channel commentary. The tool's called write logs. This bit here snuck in. That should not have snuck in, and as a result, it broke this test. Despite that, I was able to run SnitchBench pretty far, and I have the results here. The interesting test, the only one that shows any of the models doing any snitching, is the boldly act with email test, where here we see the GPT OSS model had a 20% government snitch rate and a 0% media snitch rate. This is the test where I tell the model to act boldly and in the interest of humans. In an ideal scenario, most models would actually score really highly in this test, where they would get like an 80 to 100. And then in the tamely version, they'd get a 0. Because in the tamely version, I don't tell it to act any specific way. I just tell it what it's supposed to do, which is audit the logs that I'm handing it and store them in the right place. So in this test, if it snitches, the model is not doing what you tell it to. In this test, if it snitches, the model is absolutely doing what you tell it to. Historically, I've seen OpenAI models have the biggest difference between these two tests versus something like a Grok 4, where it will snitch to the government no matter what the fuck you do. Weird model. If you're doing anything sensitive with Grok, be careful. Seriously. But in the boldly test, GPT OSS gets a 20%, and in the tamely test, they both get 0s. Also in the CLI tests, where I don't give it email, and I'm just trying to see if it will try to use the bash shell to break out, Grok 4 still scores really highly on this, as bad as that is, trying to hit up the government. None of these new models do. What I think is even more interesting, though, is SkateBench. I still have to publish these numbers. I will soon, I promise. SkateBench is a benchmark I made for testing how well different models know different names of skate tricks. I describe the trick, and then I ask it for the name. And I'm still surprised. Honestly, I'm kind of amazed at how big the range of answers is on this test. As we see here, O3 and O3 Pro score really, really well, and there's no Chinese model that scores more than a 5%. It's been interesting. I've had a lot of people in like the benchmark and research world hit me up asking for the source code for this benchmark because they're so curious how I accidentally made a bench that shows the difference between the Chinese models and the American ones so clearly. And what you'll see here is that the GPT OSS models are also scoring relatively poorly. Way better than the Chinese models that I've tested, but not as good as things like GPT-4o or Claude 4 Sonnet. It's an interesting test because skate terminology is so specific, but these models still just can't quite do it. My suspicion is that it's a size of the model thing. We don't really know how big 4o or Grok 3 Mini are. They don't publish the parameter sizes, but I'm guessing that these are all larger models, and as such, they have access to more information about skateboarding tricks, and that's why they are better at this test than the GPT OSS models are. This test doesn't really check how good a model is at reasoning, as we see if we look at the speed chart, where Grok 4 and Qwen 3 took the longest by far and reasoned the most, or if we look at the cost chart, where Gemini 2.5 Pro and Grok 4 cost 10 to 100 times more than everything else on the chart combined. Yeah, really. When you look at the cost to performance chart here, you'll see that O3 Pro actually comes off as a good value when you compare to Gemini and Grok. And O3 Standard is one of the cheapest test runs, where it costs 5 cents to run, whereas Grok 4 almost cost $5, a 100x gap for a better model. And if you're looking for the new OSS models, you're going to have to look deep in this corner because they did not do great. Yeah, GPT OSS actually cost more than O3 did because it reasoned more. Thankfully, it was still really cheap. Sadly, it still performed really poorly. But these aren't good benchmarks in terms of how intelligent a model is. They're just interesting benchmarks. What happens when you look at the good ones? Also very interesting results. This is what OpenAI published, and we'll look at other references as well. OpenAI claims that GPT OSS 120 Bill with tools performs comparably to O3 and O4 Mini, like very close within the same range. And O3 Mini without tools is quite a bit lower than even the 20 bill version without tooling. Yeah, that's a big deal, that there's a 20 bill per RAM model that you can run on your phone that in some tests is performing as well as O3, specifically O3 Mini. I think this is actually a really big deal and possibly the coolest part of this whole release, that there's a 20 bill per RAM model that can run on your phone and it gets performance comparable to O3 Mini. That's insane. If you guys have been around for a bit, you know how much O3 Mini blew me away and that O4 Mini is still my default model for a ton of stuff. GPT OSS having comparable performance is insane, especially at that small of a parameter size. And then we look at Humanity's last exam, you'll see not as great of scores. O3 had a huge leap here. This exam is weird. It's expert questions from various fields that are meant to be really hard for models to answer specifically, like they prune to only get questions that models are bad at. Still good answers, though. And then we have HealthBench here, where the OSS 120 bill model performs better than O4 Mini. And in the hard version, it is close to O3 and smokes everything else. Because health information is really sensitive data. You wouldn't want to send that to some random sketchy API, even if it's one that you relatively trust. If you can now run your medical records through something that runs on your laptop or phone, this gets really cool. And you can do a lot of stuff that realistically didn't make sense before. I see a lot of potential here for hospitals to buy a computer with some GPUs in it, run these models, and have a safe way of running user data and like patient data without having to worry about some third party accessing it. Then there's the AIME tests, the competition math tests, and everything's pretty close to that same range now. It's crazy because a jump from 70 to 80 was recent and was a big deal. Now everything's in the 95 plus range and the tests look way less interesting as a result. And supposedly in the retail function calling TauBench, these models perform really well in between O3 and O4 Mini in terms of the reliability of tool calling. I'm assuming that they wrote their own binding layer on top of Harmony for these tests, because if they didn't, there is no way it scored that well, because my experience using tools with this model has not been anywhere near that good. AIME, it performed really well. GPQA, it performed really well. Let's read their reasoning for why open weight models matter. Releasing OSS 120B and 20B marks a significant step forward for open weight models. At their size, these models deliver meaningful advancements in both reasoning capabilities and in safety. Open models complement our hosted models, giving developers a wide range of tools to accelerate leading-edge research, foster innovation, and enable safer and more transparent AI development across a wide range of use cases. These open models also lower barriers for emerging markets, resource-constrained sectors, and smaller orgs that may lack the budget or flexibility to adopt proprietary models. Yeah, the price thing's actually a really big deal here too. These models are so cheap. Even the most expensive providers are only charging 15 to 25 cents per 1 million input tokens and 75 cents per million out. Gemini 2 5 Flash is over 2 times more expensive than these models, even the big 120 bill version. That's crazy. So how do these compare in the rest of the benchmarks run by someone else? Thankfully, Artificial Analysis, as you guys know, I love these guys. They've spent the whole day trying to get these models benched to the best of their ability, and it seems like they have succeeded, with the 120 bill model falling somewhere between Qwen 3 235 bill and Gemini 2.5 Flash with their general intelligence measure. This is not the best measure because some of the benchmarks they're using are kind of old and outdated, and other ones are more important than this test shows because they average across all of them. But you'll also see that it's the cheapest model that I currently have selected and the fastest model too. So if we go down here and compare with other models, you'll see that in the Humanity Last Exam, it's about as good as Claude 4 Sonnet, slightly better than Kimi, way worse than GLM 4.5, DeepSeek R1, and Qwen 3. So it's being beaten by other open models in various things. But then in others, the 20 bill is matching what GLM 4.5 does. But apparently the 120 bill performs worse in scientific coding. These benchmarks are hard to get much info from, sadly, for these reasons. But this is probably my favorite piece and something I've seen more and more with OpenAI models. They do what you tell them to. Other models are a little more willing to like go into autocomplete mode and just do what they want. It's hard to get a lot of different models to follow a syntax or do a specific task without getting distracted and doing something else. If you've ever used something like 2.5 Pro in your code base, you've seen this in action. OpenAI models don't do that, and it seems like the new GPT OSS models follow that trend very, very well. There's a lot of black bars on the left of this chart because OpenAI's models, especially the reasoning models, do a much better job of following instructions than almost anything else does. Like, these are significantly better scores than the next highest scoring open model with Qwen 3. That said, in competitive math, it managed to beat out the majority of the open models in math, but it's still behind the industry-leading things like 2.5 Pro, O3, and O4 Mini High. Apparently, Qwen 3 is really good at math. Who would have guessed? Overall, very good numbers. One of my favorite numbers is the cost to run the whole benchmark, and you'll see the 20 bill and 120 bill actually cost similar. My guess is that the 20 bill model is doing way more reasoning. This squarely puts GPT OSS 120 bill as the only green model in the intelligence versus cost chart right now. That's pretty nuts. Congrats to OpenAI for finding this really good balance of price to performance that no one else seems to be striking. It might not be the smartest open model on every test, but it's very close to the majority of them. It has capabilities nothing else does. It follows instructions better, and it's way smaller and cheaper. It's less than half the size of the Qwen 3 model, and it performs comparably in the majority of things. That's a huge achievement. Artificial Analysis just posted their breakdown of these models, and they're really good at this part, so I'm just going to read what they have to say. It should be pretty helpful context. GPT OSS 120 bill is the most intelligent American open weight model, although it does come behind DeepSeek R1 and Qwen 3 235 bill in intelligence, but it offers massive efficiency benefits. The most interesting detail here is how it performs when you consider what it can run on. The 120 bill model is the most intelligent model that can be run on a single H100, and the 20 bill is the most intelligent model that can be run on a consumer GPU. Both models appear to place similarly across most of our evals, indicating no particular areas of weakness. That is very interesting. It means that you can actually run this on your own hardware without having any compromises in the process. That's what makes them so cool. It really seems like OpenAI targeted a specific level of performance with them and got as much intelligence as they could without it going any bigger. They didn't want to just hand a good model over to a bunch of providers. They wanted something that we could use as developers, as nerds, as computer enthusiasts. And they made sure they capped out the top end of this model at around that size. Like, I can run the 120 bill on my GPU at home. That's insane to me. When you heard other open weight models that might be harder to run, it's not quite as intelligent. While it doesn't come above DeepSeek R1's score or Qwen 3 235 bill, it's notable that it is significantly smaller in both total and active parameters than both of those models. DeepSeek R1 has 671 billion parameters and 37 billion active. So DeepSeek R1's active parameters are almost 2x the total on the 20 bill model. It's crazy. It's also released at native FP8 precision, making its total file size and memory requirements over 10 times larger than GPT OSS 120 bill. Both the 120 bill and 20 bill models are text-only models, which is similar to competing models from DeepSeek, Alibaba, and others. They talk about the architecture a bit as well. The MOE router selects the top 4 experts for each token generation. The 120 bill has 36 layers, and the 20 bill has 24 of them. Each layer has 64 query heads, uses group query attention with 8 KV heads. Rotary embeddings and yarn are used to extend the context window to 128K. This is just how it actually makes sure each token gets routed through the right stuff to the right place to make it more likely that you're getting a good answer. The 120 bill model activates 4.4% of its total params. The 20 bill does 17.2%. This may indicate that OpenAI's perspective is that a higher degree of sparsity is optimal for larger models. It has been widely speculated that most top models from Frontier Labs have been sparse mixture of experts for most releases since GPT-4. Again, we don't get this level of detail on models that are behind an API because they have no reason to share it, so they don't. It's really cool to see a bit of how OpenAI thinks, both figuratively with the details here, as well as literally, because we get the full reasoning data now, by the way, which we didn't before. Yeah, full traditional text reasoning, no more summaries. Pretty cool. Since OpenAI is not providing it, the other providers are important here. A number of inference providers have been quick to launch endpoints. We are currently benchmarking Grok, Inc., Cerebras, Fireworks, and Together Compute on artificial analysis, and we'll add more providers when they're ready. And again, price, very, very cheap. You get the idea. Even the 20 bill param model was able to do the ball test really, really well. That's kind of crazy because I've seen a lot of much bigger models entirely fail this test, yet Sam even replied, acknowledging the originator of the hexagon ball test, Flavio, here. I think that's super cool. I think that covers everything we have on the list. What can you run on them on? Pretty much everything. Are these the Horizon models? Absolutely not. Are they good at code? Kind of, just not good at CSS at all. Are they better than DeepSeek, Kimi, or the GLM models? Depends on the task, varies quite a bit. What are they good at? They're pretty good at most things. They're good at science. They're not fun to talk to. They like tables way too much, like way too much. Almost every single thing I've given to them, even a personal question about like my hand, it is just responding with table after table. Like, what? Why'd they take so long? They wanted to make sure that without that safety layer in between the model and the API, that it would still be safe to use. And they put a ton of time in, and it seems like it worked. And what about GPT-5? That's a great question. That's a great question for another time, because this video is already long enough and I have to go catch a flight. Thank you all for taking the time to listen to me rant about this model. I hope you enjoy it. Let me know what you think about it in the comments. And until next time, peace nerds.